Time to learn about atoms and molecules. Today we think of matter, all the stuff that has mass and takes up space in the universe, as being made out of atoms mostly. So atoms are the smallest units of matter that we commonly work with in Chem 65. Now there's another unit of matter called a molecule. All right? So a molecule is a certain kind of group of atoms stuck together. All right? And then there is another form of matter that we call an ionic compound. And in this video, I'm going to show you, I'm going to draw for you what you could think of when you think of these things, and what are the differences between them. All right? I'm also going to show you how we count them, but I might have to do that in a separate video. So first of all, atoms. Now, there are about 118 different kinds of atoms that we know about in the universe today, and here they are, all 118 kinds of atoms. So you see, this is a pure element. It is a kind of atom. This is a different kind of atom. This is a different kind of atom. All right? So the atoms in Chem 65 are the smallest unit of matter that we work with, which has certain properties. Okay, now here's what I mean by that. If you take properties, if you take a gold atom, right? So gold is right here. If you take a gold atom and you take another gold atom, those two gold atoms are exactly the same as far as we could see as human observers without specialized tools. So one lump of gold has a bunch of atoms. Another lump of gold has a bunch of the same atoms. And to us, gold is gold. There aren't different kinds of gold to the common human experience. It's just gold. So same thing with carbon. If you take carbon, like charcoal is mostly carbon. If you take one piece of charcoal and you take another piece of charcoal from the same bag, it's black stuff, and you get your hands dirty, and it's carbon. So it's all the same atom. Now you can cut a carbon atom. So this is a carbon atom. You can divide a carbon atom into two or more pieces, and then you wouldn't have carbon anymore. You would have something else. So for example, you might have lithium for one piece, and you might have lithium for another piece. Now lithium is not carbon. If you have a lump of lithium, it's not going to be black and crumbly, and it's not going to get your hands dirty. If you crush lithium at a very high pressure, it's not going to turn into diamonds the way carbon does. So we consider atoms the smallest unit of matter which has certain properties. If I divide a carbon atom, it no longer has the same certain properties of carbon atoms. You know what I'm saying? It's not carbon anymore. All right, so that's what we consider as atoms. And an element is just a type of atom. An element, a type or kind of atom. All right? Now, what about a molecule? If you take some atoms, let's say a carbon atom and maybe an oxygen atom and an oxygen atom, and you bind them together in a way that makes a new thing. So oxygen is a gas, carbon is a solid, but if you put carbon and oxygen together, you don't have this black solid anymore. Now you have a new gas, which is heavier than oxygen and which you can't survive if you just breathe it. You know what I'm saying? So everyone needs oxygen to survive, but if you just have carbon and two oxygens together, you can't survive anymore. So this is a new thing. It's a new chemical, a new substance. And this is what you know of from last week's work online as a compound. So this is a pure compound. This is a special kind of compound, however. This compound is called a molecule or a molecular compound. And there's a specific reason why. Oops. Okay, so here is the reason why. So atoms are made of smaller pieces which don't have certain properties, all right? So let me go get those, your model of an atom for you. Build an atom. You can do this too at fet.colorado.edu, just like me. I'm going to build an atom here. And the atom is made of certain pieces. Those pieces are protons, electrons, and neutrons. So the atom is made of protons in the middle. They are positively charged. Notice how every time I change the number of protons, the element name changes. So the element name depends on the number of protons. Atoms also contain neutrons. Look at that. Neutrons do not change the element name. It's still lithium. But if I were to take away a proton, it would not be lithium. If I were to put a proton back, it is lithium again. If I put another proton, it's not lithium anymore. It's something else, right? And then electrons. Electrons go on the outside of the atom, and they are not important to the name of the element. You see what I'm doing here? Just put in electrons, and it doesn't matter how many I put, it's still beryllium here. It looks like the only piece of the atom that matters for the element name is the protons. How about that? Okay, so you see these electrons on the outside? These electrons are where all the chemistry happens. All the chemistry that we're interested in Chem 65 and Chem 101, it all happens out here with the electrons. Let me show you how that works. So if I have a carbon atom, a carbon atom has 6 electrons. And 2 of the electrons are on the inside, and 4 of the electrons are on the outside. You want to see? Here, oops. So here's a carbon atom. A carbon. Let me build a carbon atom for you. Here we go. A carbon atom, and you see this atom has a positive charge here, but I can make it neutral if I give it 6 electrons. See, 1, 2, 3, 4 on the outside and 2 on the inside. We'll learn more about these electrons and protons and neutrons later. What's important right now is that you know that the electrons are where all the chemistry happens. When the carbon atom with 4 electrons on the outside meets an oxygen atom, now an oxygen atom has 2 electrons on the inside, this is an O in the middle, and 6 electrons on the outside. When these 2 atoms meet, if they meet and they crash into each other with just the right amount of energy, then they will start sharing the outside electrons. So here, let me draw that in a way that only shows the outside electrons. So carbon has 4 outside electrons like that, and oxygen has 6 outside electrons like this, right? I don't care about the inside electrons because when these 2 atoms crash together, the inside electrons never see what's happening. It's the outside electrons that get affected. It's just like you. When you walk down the street with your coat on and your friend sees you from a long distance away, she will see your coat first. If you're wearing a red coat, oh, there's someone wearing a red coat. She can't see your face, so she doesn't know it's you, but it's someone wearing a red coat. The same thing with the atoms. When these atoms see each other, they don't know what's on the inside. What they see first is the outside, the electrons on the outside. Right, so these electrons on the outside, they're going to get shared. So this carbon is going to come closer to here. And here, let me draw it closer here. It's going to share those electrons like that. You see that? These electrons are getting shared here, right? And you know what? These electrons can also get shared here. So you end up with sharing electrons right there, sharing electrons right there, and then you have these other electrons that are not being shared right now, right? So these electrons are getting shared. This sharing of electrons is very common among certain kinds of atoms. And when the atoms share electrons, it's called a covalent bond. A covalent bond. Bond meaning the atoms are stuck together. Covalent meaning they're sharing, that's the co part, and valent valent means outside, the outside. So the valence, valence actually means teeth, but that comes from chemistry history. Now we know of, so we used to think of atoms as having a bite to them. So this atom, these two atoms, they bite each other, and that's where the word valent comes from. But now we know that the bite only happens because of the outside electrons, and so we think of the word, this word part, valent, as meaning outside. So the valence electrons. The outside electrons are the valence electrons. Those are the outside electrons, the valence electrons. Okay, so anyways, the word covalent bond means we're sharing outside electrons. So there are many atoms that do that, and you need to know which ones do that, so I'm about to show you. And here they are. You see these green guys where it says other nonmetals? All these green guys? All these green guys make the covalent bonds with each other, including this green guy, hydrogen, that's also green. Anything green on this periodic table, it makes covalent bonds with other green things on the periodic table. All right? So that means they form molecules. A covalent bond forms a compound which is called a molecule. So a molecule really is a compound held together by covalent bonds only. Covalent bonds only. That is what a molecule means. The word molecule, it means a compound held together by covalent bonds. Now, there is another kind of bond. Actually, there are several other kind of bonds, but in Chem 65 we learn one other kind of bond, which is the ionic bond. So an ionic compound is a molecule that is not held together by covalent bonds. And since you know that the green things here, these nonmetals, since these green nonmetals commonly form covalent bonds, and the green nonmetals do not form most of the elements on this chart, you know, most of the elements here are not green. So most of these things are not nonmetals. What are they? Well, if they're not nonmetals, they're either metals or something else. So if it's yellow, purple, or pink, it's a metal. If it's blue like this, these just don't form any bonds. These are called noble gases. We'll learn more about that later. You don't have to know it right now. But these guys are non-metals, but they don't form bonds. So if it is pink, purple, or yellow or orange, it is a metal. Also, if it is this gray blue over here, these guys down here, these are also metals. Lead, obviously, is a metal. Tin is a metal. You knew that. Aluminum is a metal, yes. Okay, so most of these things in the periodic table are metals. So what about metals? Metals form different kinds of bonds with other metals. They are called metallic bonds. We don't learn about that right now. If we have time, we'll learn about that later. But what if a metal forms a bond with a nonmetal? What if a purple thing forms a bond with a green thing? Or an orange thing forms a bond with a green thing? Such as salt, right? Sodium chloride. Chloride is green right here. Sodium is orange right here. So sodium chloride. When sodium chloride forms, this is not a covalent bond. So here's the chlorine atom, here's the sodium atom. They do not share electrons. It is not with a covalent bond. Here's what happens with sodium and chloride. Sodium forms a positive ion, and chloride forms a negative ion. So this is no longer sodium that is pure. It's no longer pure sodium. This is no longer pure chlorine. This is chlorine that has been changed. It has a charge on it. This is sodium that has been changed. It has a charge on it. We'll learn more about those charges later. But for now, what you need to know is that metals and nonmetals form ionic bonds. Any atom that has a charge on it is also called an ion. This has a charge on it, so this is called an ion. So the plus ions are attracted to negative ions. Positive and negative charges attract. So the ionic bond is just the attraction between the positive ion and the negative ion. That is the ionic bond. The attraction between the positive ion and the negative ion. That's the ionic bond. Okay? So those things are ionic compounds. Sodium and chlorine, they make an ionic compound. Here, look, silver and chlorine, that makes an ionic compound. Here, calcium and sulfur, calcium sulfide, it makes an ionic compound. Cadmium and sulfur makes an ionic compound. Iron and oxygen, it makes an ionic compound, which we usually call rust or something like that. Magnesium and nitrogen, it makes an ionic compound. You get the idea? So metals and nonmetals make ionic compounds because they form ions. The metals form a positive ion, and the nonmetals form a negative ion. But nonmetals, the green things here, they only form covalent bonds with each other, and that makes molecules. So a molecule is a compound held together by covalent bonds. An ionic compound is kind of obviously a compound held together by ionic bonds, or plus and minus attractions. That's it for this video. Let me turn this off. How do you turn this? Is this? Okay.